My history starts back in 1994, where I met Jerry Yule. This is a picture of Jerry and me. Jerry passed away about a year ago, and I know some of you know him. And what he did was he reinvented the way that math is taught when Mathematica first came out. So he threw away the usual pedagogy for teaching math, and he reinvented it inside Mathematica in a classroom with students. And so I've come along and taken that from what he was doing in a classroom, or in a computer lab actually, and put it online. Over the last 18 years, I have actually overseen more than 24,000 students using, it is not computer-assisted math, it is computer-based mathematics. First of all, historically, there are the dark days of, if you all remember taking square roots by hand, who does that anymore? You still do that? I'm sorry. Most people, I think, use it. I hardly remember how, and I'm glad I don't have to do that. So what Jerry did was he created innovative Mathematica, and I didn't get a chance to go take pictures in the lab, so I had my TA pose this photo. But this is what you would see with a student working with a Mathematica notebook, and they're actually interacting. They never leave the Mathematica environment at all to do these problems. The whole curriculum is in Mathematica. What we do is we walk around and watch what they're doing, listen to their discussions with each other, and engage in a conversation with them as they're learning. I just have this real brief one, and I'm going to not really go through it. I was trying to come up with something, but here's something we do in our pre-calculus class. Monte Carlo estimation of pi using Mathematica. So we start with, God, this is scrolling funny. Mathematica puts in about, here's 8,000 points, but as a student I can change it to whatever number of points I want. Color the points inside the circle, different color than the ones outside the circle, and then figure out the area enclosed by the circle divided by the area enclosed by the box. Mathematica calculates to be 3.1675, which is a pretty close estimation of pi. So students are learning about areas of circles and good stuff like that. I'll see if I can scroll past all that stuff. Okay, we don't do introductory lectures at all in our courses, just as I said. They started using the introductory lectures, but it wasn't working out. The students weren't showing up, and actually they kind of looked like pod people when we were trying to do it, so we decided to just go in the lab. And we do actually have something called discussions, where we take them into a classroom once a week after they've learned the material, and then they're ready for a good conversation about what they've been learning. So no introductory lectures. Students learn by making math, and so we let them do creative, fun things like this, and that they just sort of make. And what they do is they take charge. The students own the math that they're doing. In Mathematica, they're allowed to author in math. It gives them mathematical typesetting. It lets them approach problems in whatever way they feel like approaching the problem. They can do it numerically, symbolically, graphically, however they feel like doing the problem. Some students do it 3 different ways to make sure they got it right the first time. So anyway, the mode of instruction that we have works really well in an online environment, which is mostly what I do these days. I'm not going to go through all this research, but I'm going to show you there is a lot of another creative thing my students did. I think it's a creepy elephant, though. Anyway, there's a whole bunch of studies, mostly done in the 90s, but some done in the 2000s. But basically what most of these are going to tell us is that our students aren't any worse off for hand calculations than the traditional student, especially 6 months after the course is over. You can't tell the difference between the two. What our students are better at is conceptual understanding of the material, even 6 months later. And 2 years later, in fact, some studies have followed them. Engineering students that we studied, with all of the students at the University of Illinois who've gone on in engineering courses that required vector calculus as a prerequisite, they were statistically indistinguishable from the students who had taken their math by paper and pencil mathematics. And the list just sort of, it goes on and on. let's see, challenges we faced. Difficult to get faculty buy-in, and even today, 20 years later, we still fight this battle. Student and faculty perception. Some students think that it's not going to teach them well enough. Usually once they're in the class for a while, they change their mind about that. I met a girl yesterday, one of my former students, online students, who lives in Cambridge. She goes to school at Cambridge. And she's a PhD student in economics. She took 3 courses from me: vector calculus, linear algebra, and probability statistics. She was singing the praises of Mathematica. She was singing the praises of the courses and how well it prepared her for her courses at Cambridge. And she also says she's using Mathematica a lot in her research. And in the recitation sections that she's going to be teaching at Cambridge, she's rethinking the way that she's going to do it. And rather than just having her students show up where she solves their problems in front of them, she's going to solve them ahead of time, put them on a YouTube video, and then bringing them in the classroom and do small group learning where they actually work on problems together. Assessments, we've worked doing formative and summative assessments. There were some challenges with formative assessments at first. I think we're starting to overcome them as we're able to have better Mathematica typesetting online, and I know some people are going to be talking about the innovations tomorrow where using Mathematica on over the web page is going to break that hurdle for us. Other things were learning management system technology issues, where when we first started, we created our own for students to work in, and then the ones created by companies started showing up, and they didn't ask us, so our stuff didn't really work. It doesn't very well work in their systems. Successes. Our students are writing about math, they're taking ownership in their product, and just like what I talked about with the girl I met yesterday, Erin, she takes great pride in what she learned and is carrying it forth to her own studies. We did learn that students do better without introductory lectures. I use mentors in my courses, so students have a student to work with that has had experience with the course before and helps them work through it, especially in the online environment, makes the course more personal. And the one thing that the students and mentors have always wanted, and this came from Erin yesterday, was that they want to see the courses run even more efficiently than they currently do. And then this is me, I'm leaving. One of my students made that. Another fun thing.